Okay, today we're going to be talking about sound waves. A sound wave is a vibration which is produced when air molecules move. Basically, what happens when you speak is your vocal cords vibrate, causing the air particles to vibrate, and then that travels to your ear and other people's ears, and then the eardrums vibrate, and then that's interpreted by your brain as sound. The speed of sound in dry air at 0 degrees Celsius is 330 meters per second. The speed of sound increases with temperature, so as the temperature goes up, the speed of sound goes up. The speed of sound, you'll notice, is a lot slower than the speed of light, and because of that, if you're if you're timing at like a track event, you usually go off of when, or you're supposed to go off when you see the gun smoke rather than when you hear it. Now they have automatic timing, so it's not really necessary. Um, that's also why you will see lightning first and then you'll hear the thunder later. Um, it also increases with more dense materials such as water. Sound waves travel 4 times faster in water than they do in air. It doesn't mean that the sound's louder, it just means it travels faster. The frequency of a sound wave, our impression of sound waves, are is pitch. Um, High pitch has a high frequency, and low pitch will have a low frequency. Humans can hear from about 20 to 20,000 hertz. Below 20 hertz is considered infrasonic, and above 20,000 hertz is ultrasonic. Um, and what do we use in the medical field with ultrasonic waves? Interference is kind of the addition or subtraction of waves based on where they happen. It can make the amplitude higher, or it can make the amplitude lower. So it can either make a louder noise or even cancel the noise out. Um, Destructive interference happens when the high portions fill the low portions and they phase each other out. This is useful for anti-noise technology. Um, Sound compressions are canceled out by mirror image refractions. Here is an image of that. Constructive, you can see in the first two there, constructive, the amplitudes are, at the same spot and it makes the amplitude larger. And then destructive interference is when, the crest is met up with the trough of another sound wave and they cancel each other out. Beats are due to interference, and this occurs when two tones of different frequency are sounded together. These are heard as fluctuations in loudness. You could use this to tune pianos, or you might even use it to help tune your instrument. Um, and that's kind of what the tuning fork purpose is. I don't know that they still use tuning forks for that, but you can get tuning forks at specific frequencies, and you can use those to make sure that your instruments are in tune. And you can calculate those by the difference in the frequency. So if there are 5 beats occur, then that means the frequencies are different by 5 hertz. And here's one practice. One tuning fork has a frequency of 460 and the other 465. What beat would this create? And you would just simply take 465 divided by or minus 460 and you get 5. And that is it for today.